सही है, ठीक।
So just a second. So Humaid, आवाज आ रही है?
Yes, sir.
ठीक है, so we're going to do we are going to do this paper. ठीक है, this is concept February March 21 question paper 1-2. ठीक है, so that's 1 second. This one February March 2021 question paper कौन सा था? 1-2. Starting with the first question. ठीक है, question ये कि the table shows proton neutron. Which pair represents the atom of two isotopes of the elements? Quickly, which ones are two isotopes of the same element? कौन सा? Same proton number, different number of neutrons, right?
Neutrons, yeah. X and Y.
नहीं, W and Y. क्योंकि उससे he used the word atoms, right? Atoms are what? Neutral. तो neutral होना चाहिए. 32 protons, 32 electrons. 32 protons, 32 electrons. X is an ion, although X is an isotope, but it is an ion, not an atom. ठीक है? Is that clear?
जी.
As the next one, where in the periodic table is the element that has an outer shell electronic arrangement of 4s? When do you have 4s2, 4p3, s2p3? Which group does this element belong to?
15, sir.
15, right? You remember okay, data booklet mein if I have a look at the periodic table, the first group 1 is always S1, group 2 is always ends with S2, then it's going to be S2P1, then it's going to be S2P2, then all the electronic configurations in group 15 will be S2P3. Okay, so this element, whatever this element is, it's going to be in group 15. Okay, so group 15, and the period is the shell number, that's 4. So the answer is D. As the next one, there's a substance, Q is a hydrocarbon. When 1 gram of Q is completely burnt, so it produces 3.22 grams of carbon dioxide. So we just have to figure out by trial and error which one is the correct answer. So can anyone tell me what the formula of cyclohexene is? Or what is, like, how many carbons would it have, cyclohexene?
6.
ठीक है. And it's
like a benzene.
नहीं, लेकिन benzene में it's hexene will just have one double bond. ठीक है. So there's going to be 1H, this will have 2 H's, this will have 2 H's, this will also have 2 H's, and this one will also have 2 H's. So the formula is going to be what? C6. And क्या होगा? H is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
10.
As a C6H10. Now, when you burn C6H10, how many carbon dioxides will be produced? 6 carbon dioxide, right? 6 carbons, so it's going to produce 6 carbon dioxides, right? Is that clear?
Yes, sir.
So now try and figure out. What if I have 1 gram of this? Will it produce 3.22 grams of carbon dioxide or not? Moles nikalo na, how many moles do you have? What's the MR? That's 12 into 6 plus 10 hydrogens. 12 into 6 is 72, I think. Either confirm or double check. Is the MR 82 or not?
Yes, sir, it's 82.
So what are the moles that you're getting?
That's at 0.0122.
You get 0.0122. So the moles of carbon dioxide will be 6 times more. So this is 0.0122. This will be 6 times a multiplier. What do you get?
0.0732, sir.
Yes, sir.
So multiplied by the MR, which is for carbon dioxide is 44.
3.22.
So A is the answer. So substance Q is a hydrocarbon, and this information exactly matches substance A. Is that clear?
Yes, sir.
sir.
बाकियों के लिए match नहीं करेगी. Pentane, it will be 5 carbon dioxide. So the moles will come out to be different and the mass will come out to be different as well. As anyways, there's another question on moles. Chemists thought indium oxide had the formula INO. By experiment, they showed that 4.4 grams of indium combined with 1 gram of oxygen to produce 5.8 grams of indium oxide. So you have to figure out the AR of indium. Okay, that's what you need to find out. So just 1 second. So that's what you have to find out. The formula of indium oxide. So he's already given you that that the formula is INO, right? How do you approach this question? How do you figure out the AR?
Write out the equation first, sir. Is it?
We write an equation, उसके moles balance करके mass दिया हुआ है MR उस तरह निकालेंगे.
You don't have the. I mean, what equation? It's just indium reacting with 1 gram of oxygen, right? So indium is reacting with 1 gram half oxygen molecules, right? I don't even know what, and it's forming INO, right? So there's 4.8 grams of indium, and there's 1 gram of oxygen that's reacting with it, and it's forming 5.8 grams of indium oxide. Okay, that's what's given. So they gave us the formula. So what's next? How would you do this?
Sir, we can use the ratio method to find the formula.
हाँ पहले moles निकालो ना, like how अच्छा क्या ratio method? What's the ratio method?
Sir, like divided 1 by 16 and then doing.
As simple
So
as this.
find number of moles of O2 first, sir.
Yeah, you can do that. There's one way of doing this is the moles of indium and the moles of indium oxide are going to be exactly the same, right? Because according to the equation, it's 1:1, right? Formula, there's only one indium, right? So there's one indium that's forming one indium oxide. Okay. So that means both of them will have equal number of moles. Okay, it's 1:1. So can you figure out the moles of indium? How do you figure out the moles of indium? That's moles is mass divided by molar mass. Sorry, AR. I don't have the AR. So I'm going to take it as X. So the moles of indium is 4.8 divided by X. The moles of indium oxide will be mass divided by molar mass, 5.8 divided by the MR of indium oxide, which is, I don't know what indium is, but I know what oxygen is. That's 16. So both of these moles will be equal, right? Okay, equation says that it's 1:1. So that means 4.8 over X is basically equal to 5.8 divided by X plus 16. And then you try and solve this. Is this part clear?
Yes, sir. Sir, Indium exist ही नहीं करता periodic table में.
करता तो होगा, उसने दिया हुआ है
तो
कि
फिर-
Group 3.
नहीं, देखो इसके अंदर ना क्वेश्चन, he's even given you the AR of oxygen, and he's saying what value of AR of indium is calculated using these data. वैसे why don't we just have a look at it? It's 114.8, right?
Yeah.
तो फिर क्या question है फिर? So there's nothing in the question. It's 114, so it's probably going to be this one. But 114.8 is basically an average atomic mass, right? So if I just go back, I mean, purely तुक्का लगाना है, तो that's going to be 115, right? Because the other ones are too off, right? So you don't even have to do, I think you don't even have to do any calculations for this.
Sir, ये इतना simple क्यों दिया है इन्होंने?
ये मुझे भी समझ आ रहा है कि why, मतलब what's the point of giving all this information?
The rest of the paper is probably horrible, sir.
Huh? Nee, but
The
still,
rest of the paper is probably
as any
horrible.
first thing, find, I mean, let's do the moles part first. You can figure out what the answer is. 4.8x plus 16 times 44.8 is equal to 5.8x, right? So if I take this side to that side, it's going to become 5.8 minus 4.8 is what?
1x
1x?
और जी और
And what?
4.8 into 16 आ रहा है 76.8.
So we're getting 77, right? Let me check the answer for this one. Question number 4. Question number 4 is B. It's 77. So basically they took a wrong value. But again, it's still, so basically they took a wrong value. The periodic table says that I mean, where's indium again? The periodic table says that it's 115, right? While the actual, Atika, you had to actually solve this. So he didn't actually, did he say that they took a wrong value? He didn't say that. He's just saying what value of the AR of indium is calculated using these data. So based on this data, the value of indium is 77. So periodic table wala agar aap karte na, you would have gotten the wrong answer. Is that clear?
Yes, sir.
Okay, but is this clear how to solve the question?
जी.
As a next one, in which substance are only intermolecular forces temporarily induced diopose, van der Waals forces, basically? So HCl, what type of intermolecular force will it have?
Is it permanent dipole, sir?
It's going to be permanent dipole because H will be slight positive, Cl will be slight negative. What about methanol? What type of what is the strongest intermolecular force in methanol?
Hydrogen bond, sir.
Okay, so when you have OH, it's a highly polar molecule and it's going to have hydrogen bonds. What about water? That's also hydrogen bonds, right? So that leaves you with octane. Octane is the only one that's going to have van der Waals forces because the hydrocarbon chain is essentially non-polar. Okay, so the hydrocarbon chain is non-polar. Any hydrocarbon chain, remember, carbon and hydrogen have pretty much the same electronegativity, so any hydrocarbon chain is non-polar. So only that will have van der Waals forces. A solution contains 0.25 grams of sulfur in 1 dm cube of water, sulfur dioxide in 1 dm cube of water. What volume of sulfur dioxide measured at 50 centigrade in pressure must be added to 1 dm cube to produce this solution? So first thing, there is, so what volume must be added? So basically we've got 0.25 grams of what? Sulfur dioxide, right? So he's basically saying what is the volume of this gas? And he's not asking it at room temperature. So if you're not talking about a gas at room temperature, the कौन सी equation use होती है?
PV is equals to nRT.
Okay, so we have to apply P is equal to nRT. So P is given, that's 1 into 10 to the power 5 pascals. It should be in pascals. Volume is given as 1 dm cube. No, it's not 1 dm cube. Volume is the one that we have to find out. Well, the volume of water given, है ना कि उसके अंदर dissolve किया था. So we need to find the volume of gas, not this volume. Moles we can find out. What are the moles? It's going to be 0.25 divided by SO2 क्या होता है? That's what's the AR of SO2? That's MR, 32 plus 16 plus 16, so that's 64.1 to be exact. R is 8.31. Or temperature क्या होता है? That's 50 centigrade. What is it in Kelvins?
Plus 237.
273 होता है.
3237.
So find out V.
Uh, 1.05 into 10 raised to 1 minus 5.
1.05 into 10 to the power minus?
4.
और ये क्या होगा? Meter cube, cm cube, dm cube, what? PV nRT, what's the unit for volume? That's always meter
Meter cube, sir.
So now you have to convert this into cm cube because the answers are in cm cube. So how do you go from meter cube to cm cube? Into 10 to the power 6. Basically, you have to multiply twice by 1000. And that would probably give you D.
G 104.8.
ठीक है. अच्छा, इसमें बस units. PVG NRT is all about taking care of units. You have to be careful about units. Pressure is pascals, volume is meter cube. R is 8.31, T is in kelvins. As our next one, an experiment is performed to determine the enthalpy of combustion of ethanol. The data collected are shown: mass of water, mass of ethanol burned, temperature rise, molar mass of ethanol, specific heat capacity. Which expression can be used to calculate the enthalpy of combustion of ethanol? First thing, the heat energy is being absorbed by the water. So how do you calculate heat energy? Q is equal to MC
Delta T.
or specifically minus MC delta T hota hai, theek hai? If you take delta T as the final temperature minus the initial temperature. So because exothermic, endothermic, so it's minus MC delta T. So the mass of water is what? W. As a mass of ethanol burn, we don't care about the mass of ethanol burn. Okay? I just care about this part, the heat that is absorbed by the water over here. The temperature rise of water, that's y degrees centigrade. Specific heat capacity of water is 4.2. And the temperature rise is y. वो rise कर रहा है ना, तो you should understand that it's going to be exothermic. It's going to have a minus sign. As anyways, that's your Q, MC delta T, right? What's the next step? Like enthalpy of combustion of ethanol is for how many moles of ethanol? 1 mole के लिए होता है, ठीक है? So how many moles of ethanol did you burn? You burnt X grams of ethanol. So you burnt X grams of ethanol. Moles में क्या होगा? X divided by Z, because Z is the molar mass. So you basically burned mass divided by MR these many moles of ethanol. And the amount of heat that is produced is minus W times 4.2 times Y. Yeah, that's you burned X grams of ethanol, which is X divided by MR, which is given as Z. These many moles produce this much energy. Is this clear?
Yes, sir.
So enthalpy of combustion is for 1 mole. So if you had burned 1 mole of ethanol, what would it be? So X would come out to be what? X would come out to be minus W times 4.2 times X divided by what? Sorry, ये X नहीं है, this is Y.
Y.
अच्छा, फिर divide by what? X over Z. So X and it will get multiplied by Z, right? अच्छा, ये हो गया. And then remember, MC delta T is all in joules. So we're dealing in joules at the moment. So what we have to do is we have to convert that into kilojoules. So for that, I'm going to divide the whole thing by 1000. क्योंकि उससे क्या kilojoules per mole में निकाला. So that's divided by 1000. So 1000 X must be at the bottom. So it's going to be A minus 4.2 W, Y, and Z. W, Y, and Z and 1000 X. Is this clear?
जी सर.
बाकियों clear? Rehan clear? Umair, is this clear?
Yes, sir.
सर आपने कहा था कि mass of ethanol doesn't matter. Why?
Which part में था? If heat energy produced करो, that's all the heat energy is going into water, right? So I was just focusing on the water, like how much heat is produced that is absorbed by the water. So Q is equal to MC delta T was all about क्या आप water का temperature measure कर रहे हो ना?
जी.
So the heat is going into water, so I just care about water, like what's the mass of water, what's the temperature change of water,
Right.
what is the specific heat capacity of water, ठीक है? Is that clear?
जी.
वो ethanol तो बाद में आया था, because he was saying, so we learned that कि यहाँ पे how much X grams of ethanol was burned, and that produced this much energy, right? तो फिर हमने ratio लगाया कि if this much produces this much, then 1 mole would produce how much, and we got this, ठीक है? Clear? Achha, next one. Question number 8. There's an oxidation state of Cl. वो कह रहा है that's what? Achha, the oxidation state of Cl is -1 in this and in this. Which row about this reaction is correct? What's happening to? Achha, what is the oxidation state of vanadium over here? Cl उससे क्या है? It's -1. Oxygen is -2. So what is V? -2 is twice. Cl is once. So what is V? Okay, it's going to come out to be what? +5?
+5.
That's 5, sir.
इधर बता दो क्या होगा? In VOCl2.
Four.
+4.
अच्छा, ये +4 है. So what's happening? It's getting reduced, right? +5 to +4. And what's happening to iodine? It's going from -1 to 0. So that, I mean, the obviously the other one is getting oxidized. Okay. I say, in which reaction is water behaving as a Bronsted-Lowry base? What's a base? What does a base do?
Accepts proton.
Proton accepts, sir.
Okay, so it accepts H+1. So यहाँ पे who's the one that's accepting H+1 ions? बल्कि water, where in which equation is the water accepting H+1 ions?
Second equation.
हाँ, क्यों water जब करेगा ना H+1 accept, what will happen to it? It will become H3O +1. There's going to be an extra H+1 that's attached to it, so it's the second one. It's P, you had water, and now water is H3O plus 1. Okay, is that clear? So that's P. Baki Saramana, it's probably, I mean, the first one, it's not doing anything. That's a redox reaction over here. Water is losing in H plus 1. Over here, water is also again losing in H plus 1. It's becoming OH minus 1. As the next one, a large excess of marble chips with 25 cm³ point of 1 mole per dm cube hydrochloric acid at 40 centigrade. So there's some reaction. How is the result different when the reaction is repeated? So he's using a larger volume and a lower concentration at the same temperature. So will the reaction be faster or will it be slower?
So I feel like it's
Slower?
slower but produces more.
Okay, so it's slower. The first thing, it's slower because it's got a lower concentration, right? So when you have a lower concentration, the reaction is going to be slower. But the moles are more. Like, how many moles do you have over here? That's 25 into 1. What do you get? 25 into 1 divided by 1,000. That's, I mean, this has more moles.
So the first one is 0.025.
And this one would be 0.03. This is more moles. So that means more of the products are going to be produced in the second one because you're adding more moles in total. Is that clear?
Yes, sir. Yes, sir.
Yes, sir.
That's the next one. Boltzmann distribution. How does the diagram appear if the reaction mixture is at a higher temperature? What happens? This is your high energy side, and this
Shifts
is your
towards right.
TK. So you get more particles at the higher energy side and fewer particles at the lower energy side. So it shifts to the right. TK, the number of particles at the higher energy end, they would be more. At the lower energy end, they would be less. So what will happen to the activation energy? Nothing would happen to it. Activation energy of the catalyzed and the uncatalyzed reaction would stay wherever they are. So nothing. So the first one is wrong. The curve is unchanged. It is obviously changed. The value of, the values of both EA and EA decrease remain this. It's D, right? Nothing happens to the activation energy. Only one thing that changes activation energy, and that's your catalyst, which that's your catalyst, which is they've already added the catalyst, so you can't do anything. You clear enough? So there was no mention about the curve, by the way, in this question. Now the next part is which observations are made when a sample of silicon chloride is added to a beaker of water. So what will happen? This is inorganic chemistry. Jaldi se batao कि SiCl4 with water, what does it do? SiCl4 with water. It's the reaction of chlorides with water. TK, 4 pages. TK, memorize all of this. So SiCl4 with water, it's a hydrolysis reaction. TK, this is all hydrolysis. Chlorides with water. So SiCl4 with water, it will be SiO2 or SiOH4 plus HCl. So you're going to see a solid precipitate, and you're going to see HCl, a very acidic solution forming, and you'll see fumes of HCl as well in this reaction. So iska jo kahan gaya ye wala. So no, visible, that's wrong. You of steamy fumes. So it's going to be B. Okay, is this clear? A solid precipitate and steamy fumes are going to be seen. I said next one. Which row is correct? The first ionization energy of phosphorus is greater than that of magnesium. It's across the period. What happens across the period? When you move across the period, the ionization energy increases. It dips at group 3, increases again. For group 6 ke upar, it dips again and then continues to increase, right? So this is sodium, this is magnesium, aluminium, there's a dip, silicon, phosphorus, sulfur, there's a dip, chlorine, and then argon, right? Now this one. We've got this reaction, what does he say? First ionization energy of phosphorus is greater than that of magnesium. That is true. Phosphorus is over here and magnesium is over here. So is the reason true or not? Why do the ionization energies increase across the period? What's the reason for that? Why do the ionization energies increase across the period?
So the distance of electron from the nucleus decreases.
No, but the main reason.
Proton number increases.
Yeah, you have
Atomic radius gets smaller.
So basically, you have more
Charge
protons.
density increases.
Basically, main reason, more protons. When you move across the period, you got more protons, right? So it has nothing to do with orbitals. So the reasoning is wrong. You just have more protons across the period. You have the same number of shells. The shielding remains the same, and the distance slightly decreases. I said the next one, the melting point of phosphorus is greater than that of magnesium. That statement in itself is wrong because if you look at your notes, inorganic. So if you look at your notes, phosphorus is a simple molecular structure. It's got a very low melting point. Magnesium is a metal, it's got a high melting point. So that is going to be wrong. So this one over here is wrong. The atomic radius of phosphorus is smaller than that of magnesium. That is true. When you move across the period, the atomic radius, it does decrease. Why? Because you've got more protons. There's more attraction when you move across the period. So the atomic radius of phosphorus is smaller than magnesium. So phosphorus has greater nuclear charge, and that reasoning is true. There's more positive charge in the nucleus. Phosphorus has 15 protons, while magnesium only has 12 protons. So there's stronger attraction in phosphorus, which makes it smaller. Okay? So you clear that option C is the correct answer. Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
So next one. Which rock correctly describes one property of barium and one property of its oxide? So observation, barium metal is added to water. Will it be a vigorous reaction or not? Rapid effervescence or a few gas bubbles?
Vigorous.
It's going to be vigorous. Group 2 में याद रखना कि group 2 में when you go down the group, where's group 2? So when you go down the group, the reactivity, it increases. And the reactions, they become more vigorous. When they react with water, they have more and more vigorous reactions. One second. So they've got more and more vigorous reactions when you go down the group. So it's going to be rapid effervescence, right? And barium oxide, when you add barium oxide to water, is it soluble or less soluble or more soluble? What's going to happen?
Very soluble.
You get the down to the group, solubility increases. Again, look at the notes. The solubility of the oxides and hydroxides, they become more soluble. So barium hydroxide is going to have a very, very high pH because it's going to be it's going to be extremely alkaline. So pH क्या होगा? That's going to be 13. So D. Okay. I said next one. Anhydrous white salt Z is heated strongly for 30 minutes. A mixture of gases is given off. Mixture, right? Remember that mixture of gases. So we say, which thing decomposes to produce a mixture of gases? Remember, there are only 2 decompositions in your course. 3 actually: hydroxides, nitrates, and carbonates. So there was no options. Is it going to be a nitrate or a carbonate?
A nitrate, sir.
Okay, so that's going to be a nitrate because a mixture of gases will be produced. So you're going to get barium oxide plus NO2 plus O2, or same in the other nitrate as well. The solid remaining in the test tube is then dissolved in water. A small amount of dilute hydrochloric acid. The addition of a few drops of sulfuric acid to the test tube causes a white precipitate. Now, this is a test for cations. So, which of the cations produces a white precipitate with sulfate? Like, what's the test of SO4 minus 2? I mean, if this is salt analysis. If I mean, if you this is your related to your practicals. Just 1 second. एक second. Where's acid basis salt? Just a second. This one. Remember salt analysis. The test for barium ions is that you can add sulfate and it will form a white precipitate because BaSO4 is insoluble. So the answer to this is that it's barium. Remember, a sulfate test is always for barium ions, or a barium ion test is always to check whether you've got a sulfate or not. Is that clear?
Yes, sir.
Next one. Chlorine gas reacts with aqueous NaOH. The oxidation number of chlorine changes from 0 to -1 and also from 0 to +1. Under which condition does the reaction? Now, this is again in organic chemistry, and there's a specific reaction where bleach is produced. That is this one. In group 17, chlorine reacts with NaOH and NaCl, NaClO, and H2O is formed. If chlorine reacts with hot NaOH, it produces NaCl, NaClO3, where the oxidation state of chlorine is +5 and water is produced. Now, in this case, he's talking about the first one, that Cl is -1. Over here, Cl is +1. Sodium chlorate 1 is produced. So he's talking specifically about cold NaOH in this case. So it's cold dilute alkali. So it's going to be A. And since you've got Cl lines, the color of the silver salt or AgCl is going to be white. That's going to be white. These are the tests of silver salt. Silver chloride is actually white. Bromide is a cream precipitate. With the I-1, it's a yellow precipitate. So let's try and complete the last 3 questions. Now, this question, TK, it's going to come in your paper. It always, I mean, this is the favorite question. Concentrated sulfuric acid reacts with sodium iodide. The products include sulfur, iodine, hydrogen sulfide, and sulfur dioxide. Which statement is correct? Now, this is again a reaction of sodium salts with sulfuric acid. The first one does not undergo any redox because Cl-1 does not like to lose electrons. It's a small ion. It attracts electrons very strongly. So Cl-1 never loses electrons. And it's going to form, it's going to have a displacement reaction, that's it. But when you go down the group, Br-1 and I-1, they really like to lose electrons, which is why what happens is that you get a redox reaction. And he's talking about I-1, so you get a redox reaction. I-1 gets oxidized. It turns into iodine, and the sulfur gets reduced and turns into sulfur dioxide or sulfur or H2S. So if we go back, which statement is correct? So all sulfur products are a product of reduction. So I think the first statement is true, that the sulfuric acid where sulfur has an oxidation state of +6 turns into hydrogen sulfide, which is H2S, where sulfur has an oxidation state of -2. So that is reduction. So that is true. The others are incorrect. Iodide ions are acting as a reducing agent, not as an oxidizing agent. When something loses electrons, it acts as a reducing agent. Sulfur atoms from the sulfuric acid are both oxidized. No, they're only reduced. Okay, remember in this case, only one thing is oxidized, and that is I-1. It loses electrons. All the rest of the sulfur products are a product of reduction. As the next one. You clear any question? Is this clear?
Yes, sir.
Yes, sir.
The next one is there's NO, NO2, CO, and unburned hydrocarbons are present in the exhaust gas of internal combustion engines. When catalytic converters are used to remove these compounds from the gases, redox reactions occur. What happens to the compounds? So what does NO and NO2 turn into in a catalytic converter? Like what happens to them? Kya, what does a catalytic converter do? It turns them into nitrogen. And what it does to the unburned hydrocarbon and carbon monoxide, it turns them into carbon dioxide and
Water.
so the N gets reduced. Both of them, they get reduced. And the carbons in both cases, they get oxidized. Okay? Again, this is inorganic chemistry, nitrogen and sulfur. Where's catalytic converter? It's somewhere over here. That I mean this part. Both carbon monoxide, nitrogen oxides, they get oxidized, they turn into carbon dioxide and H2O. Okay. As the next one, 19 or 20. There's methylamine. He says that it has similar chemical properties to ammonia. NH3, methylamine reacts with HCl to form a white crystalline salt, which is methyl ammonium chloride. So what it's doing is I think it's acting as a base that it accepts an H+1. Why is it able to accept H+1 ions? Because this is CH3 NH2, right? N has a lone pair. So the H+1 gets attracted to it and ends up forming a dative bond. So this is what's happening. This is ammonia does exactly the same thing. TK, clear? This is a reaction and it's acting as a base. Is this clear?
Yes, sir.
Yes, sir.
So what will happen if it reacts with, I mean, Cl-1 is right next to it. TK, that's just a spectator ion. What will happen if it reacts with NaOH? So now we have to think of this reaction as a reaction of ammonia. You're seeing it behaves in a similar way as ammonia. So if I reacted with NaOH, now OH ions are basic, right? So what's going to happen is, well, kiska reaction uska likh lete hain. What happens if an ammonium salt reacts with NaOH? What is going to be the product? Kisi ko idea? What will the ammonium ions behave as?
So the products are salts and water and ammonia gas.
The salt is going to be NaCl. What happens is it's an acid-base reaction. The ammonium ions, they lose the H+1 and the OH ions, they accept an H+1. So the OH ion, it gains an H+1, it forms water. The ammonium ion loses an H+1, so it becomes NH3. So kind of the same thing would happen in this case as well. The only difference is that you have a methyl ammonium ion. Or se pehle kaha hua tha ki they behave in exactly the same way. So you've got NaOH. So the salt that's going to be produced is NaCl. The OH ion will accept an H+1, so it will form water. And the methyl ammonium ion would lose NH+1. Okay, that will lose an H+1, give its H+1 to OH ions. So what you'll get is NaCl, water and methylamine. Okay, so but remember this reaction that when he says that it has similar properties to ammonia, so that means everything is behaving in exactly the same way as ammonia. So यहाँ पे ना you had NH4 plus 1 Cl, that's any ammonium salt. When it reacts with the base, it loses the H+1, gives it to OH ions. OH ions become water, and NH4 becomes NH3. And whatever is left, that's your salt. The same thing when it happens to methyl ammonium chloride, it would lose its H+1. The OH ion will accept an H+1, it will form water, and that will form methylamine back again. Okay, is this part clear, this one?
Yes.
Yes.
Okay, so we'll start with 20 tomorrow then, right?
Okay.
So, and let me add this. Okay, we'll.
So tomorrow, is it, what time is it, sir, the class?
Same time.
Same time. Okay, sir.
This was M18 question paper 2, right? No, this one was just a second. This is M21. Okay, we're going to continue with the same paper next time. Okay, everyone.
Sir.
Yes.
So I had a few questions to ask you, sir, related to my mocks, sir. First of all, sir, today the science teachers, they revealed the mocks with our mock results. So apparently what came as a surprise to me is that the teachers said that they have to send the mock results to Cambridge, and so they act as a like essentially a tracing mark, so that they have an idea of what we're going to score in the actual marks. Is that actually something that happens, sir? Is that common practice?
No, that's not. Yeah. I mean, it's I don't know about your school, but no one actually sends the mock results to Cambridge.
It's only it remains in the school, right?
It didn't even happen in the COVID part as well, where they said that you had to store the data, and they did ask schools to collect the data, but the data never actually went to Cambridge.
Oh, okay, sir. And so one more thing that yes, I continue, sir.
He asked the question. What's the question?
And so the second one was so just wanted to confirm that the enthalpy change of atomization, it's not in ES syllabus, right?
Yes, that's no longer in your syllabus.
Because it showed up in my chemistry MCQ paper, and I was quite surprised there as well.
Here's the 2022-24 syllabus. It's nothing to it, but it comes up in a lot of past paper questions. I can double check this one. Yep, it's 23. It's enthalpy change of atomization. That's A levels now. Is that clear?
Okay. Yes.
I mean, so it's officially no longer part of your syllabus for AS.
Okay, sir.